A semicircle of radius 8 rocks back and forth along a line. The distance between the line on which the semicircle sits and the line above is 12 centimeters. As it rocks without slipping, the semicircle touches the line above at 2 points. When the semicircle hits the line above, it immediately rocks back in the other direction. The distance between these 2 points in millimeters is closest to. So here is a diagram that illustrates what the question stem is talking about. And you'll notice that the dotted line here is the semicircle in its original position. And then what this diagram shows is that the semicircle then is tilted so that it is now in this position. And when that happens, it hits the line above at point Q. And because of the symmetry of this diagram, when it rocks back in the other direction, it will probably hit around here. But we don't need to be concerned about that yet. We just need to figure out this distance from Q to P, and then double it, and we will get the answer to this question. So let's begin. The first thing you'll notice is that the center of the semicircle originally was right here. But when it's tilted, that center is now here, the point that is labeled O. So therefore, the distance from O to Q is the radius. And that, they tell you, is 8 centimeters. So I will put 8 right there. Now we need to figure out as many distances as possible. So the next one that you can figure out pretty quickly is O to Z, that distance right here. You know that from this point till the bottom is just the radius, and that's going to be 8. And they tell you that the line above is 12 centimeters. So that means that P all the way to the bottom is 12. So that means that this distance is 12 minus 8, which is 4. And therefore OZ will also be 4. So let's draw this triangle QZO on the side here to avoid making this diagram messy. So here is Q, here is Z, and here is O. And we figured out that that's 4. And this is, of course, just the radius, so that's 8. And this is a right angle. So now, using Pythagoras, I can figure out QZ. QZ squared is going to be, add that to 4 squared is equal to 8 squared. And therefore, QZ squared is going to be 64 minus 16, which is 48. And therefore, QZ is root 48, or 4 root 3. So that takes care of QZ. Now, we need to figure out QP, the distance from here to here. So how do we do that? Well, we have QZ. If we can figure out the distance from P to Z, then we will be able to solve this question. So QP is going to be equal to QZ minus PZ, like that. So we are now going to try to figure out the value for PZ. Well, QZ we just calculated as 4 root 3. Now I want you to concentrate on this triangle here. Notice the side lengths. If you look at the side lengths, and in particular look at the ratio, you'll notice that the ratio of the side lengths are 1, 2, and root 3. And because that is the ratio of the sides, this is a 30, 60, 90 triangle. This is 30 degrees, and this is 60 degrees, and that we already know was a right angle. Now, how does that help us? That helps us, hopefully, figure out PZ, since that is what we're trying to figure the distance of. But how does that help us? Well, look back at this original diagram and let's fill in the 60 degrees. That 60 degrees is right here, correct? So that means this angle here is 30 degrees. Okay? Now, pay close attention. This semicircle moved from here to here. Did you notice that? It was here, and when it rotated, it went up to here. How many degrees is that? It is 30 degrees. So that means this semicircle rotates 30 degrees when it goes from this point to point Q, which is the point that touches that top line. And that 30 degrees is very important because it tells me that the distance from here to here, x to y, is essentially a fraction of the circumference of that circle. What is the fraction? 30 degrees over 360 degrees. So that is the key to the question. xy, this distance that this semicircle travels, initially it was right here at x when it was touching the base, but then once it tilts, it touches the base at y. And we want to know what is the distance between x and y, because x and y are similar to p and z. If we can figure out the distance xy, xy is the same as pz, and that is what we want to figure out. Well, xy, as I previously mentioned, is calculated by the fact that this semicircle tilts 30 degrees. So 30 degrees divided by 360, which is the full way around, that is the fraction of the circumference that travels from x to y. All right, so the distance from x to y is 30 over 360 times the circumference of that circle. Now, 3 over 360 is 1/12. The circumference of the circle is pi times 2 times the radius. So this just becomes pi over 6 times the radius, and the radius of this circle is 8. So this looks like 4 pi over 3. All right? So that is xy, but remember xy is the same as pz. So therefore pz is equal to 4 pi over 3. So going back to this formula right here, qp is equal to qz, which is 4 root 3, minus pz, which is 4 pi over 3. And if you take out your calculator and you get an exact value in decimals, you will get 2.741 approximately. Now remember, QP is only half of the distance we are looking for, because if you go back to the question, you'll see that when this semicircle rocks back and forth, it will touch the top line at 2 points. And therefore, the other point is going to be somewhere, let's say here. And because of the symmetry of this diagram, the distance from P to that point is the same as the distance from P to Q. So since we got QP, we can just multiply QP by 2 to get the total distance. And therefore, QP multiplied by 2 is approximately 5.483 centimeters. And if you multiply by 10 to get millimeters, you get about 54.83 millimeters. And if you round that to the closest integer, it will be 55. And therefore, number 25, the answer is A.